Hello everyone. The title of this video is Use the Distance Formula. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. It is their Intermediate Algebra 2nd edition text. And I'm in section 11.1 titled Distance and Midpoint Formulas, Circles. And I'm working under the heading Use the Distance Formula. Alright, I'll be working on just the even numbered exercises, 2, 4, 6, and so on, up until 12. Alright, and these are the exercises that don't have links to solutions. Alright, you may notice that the odd numbered ones have links to solutions that you can click on, so I'm not going to be doing those. I will also have timestamps for each exercise, each example in the description of the video below. Example 1's timestamp will be for number 2, example 2 for number 4, example 3 for number 6, and so on. I also request that whenever I start a new question, pause the video and try to work on it yourself first before watching me do it and then comparing. Because if you're just watching me do these questions and not practicing them yourself, chances are you're not learning all that much. Alright, so in each of these exercises, we're asked to find the distance between the points. That's how far apart are they? How many units apart are they on the xy coordinate plane? And we're asked to write the answer in exact form. Now, exact form just means, don't punch it in a calculator, don't round it. Just leave it the way it was. And then find the decimal approximation, rounded to the nearest tenth if needed, if it's not a whole number. So then, after writing it in exact form, we're asked to, use a calculator, punch it in a calculator, and round to the nearest tenth. Alright, so exercise 2 is the first one I'm doing. I've got these written out. So that's example 1, exercise number 2 from the text. Alright, so we have -4, -3, and 2, 5. Alright, so I'm going to make a very rough hand drawing of this. I'm going to try my best. Now, if you have graph paper, that would be wonderful. Here's the xy coordinate plane. And I'm going to plot these 2 points, these 2 locations. So the first one has, -4 for the input, -3 for the output, right? So -4 on the x-axis, -3 on the y-axis, right? And we're talking this location right here. That's in line with both of them. Okay, so there's the ordered pair, the point -4, -3. And then the point 2, 5, right? So +2 on the x-axis. And I go to +5 on the y-axis. And I'll plot that location. There we go there. Alright, so what we're asked to find is the distance between these 2 points. Alright, how far apart are they? Alright, so I'm just going to do a little dotted line here connecting the 2. If I was going to go from one straight to the other in a straight line, I'll call the length of this side, I'll call the length of this segment d units for distance. Alright, so the length of this segment is d units. Alright, so how we're going to find this is through use of the Pythagorean theorem. All right, let me show you. What I'm going to do is I'm going to draw a right triangle in this picture, in which I travel from one point to the other, but instead of going straight there, I'm going to go right, left, and up, down. So if I was starting here at the point -4, -3, and I want to go to the point 2,5, first I'll travel to the right. Right, so I'm traveling to the right. And I travel to the right until I get underneath 2 here. And then I would travel up until I get to y = 5, until I reach that point. And hopefully you can see the little dotted right triangle that I've created here. This is I made a right angle turn here. Now these lengths, right, the lengths of these legs, I actually know. And we can calculate them. This horizontal leg, I'm going from x is -4 all the way over to x is +2. How many units is that? That's 1, 2, 3, 4, 5, 6 units. Which I could have calculated by taking 2 minus -4. Right? This is just the change in the x-coordinates. The change in the x-coordinates. The change in the x-coordinates gives me the length. And really, if you did it the other way around, if you did -4 minus 2, just take the absolute value, just make it positive, you'd get +6. The change in the x-coordinates gives you the length of the horizontal leg of the right triangle. And now let's look at the vertical leg. I was going from y is -3 up to y is 5. That's 1, 2, 3, 4, 5, 6, 7, 8 units. Which again, I could have calculated by taking 5 minus -3. Alright, that'd be 5 plus 3, that'd be 8 units. So you see this vertical leg is just the length of the vertical leg is just the change in the y-coordinates of those points. And now I apply the Pythagorean theorem. Right, by the Pythagorean theorem, since I'm dealing with a right triangle here, (6 squared plus 8 squared) equals, the length of the hypotenuse, which is what I'm trying to find. Right, the hypotenuse is that longest side of the right triangle, the side opposite the right angle. 6 squared plus 8 squared will be equal to d squared. Right, this distance between the 2 points squared. Well, that's 36 plus 64 equals d squared. 36 plus 64 is 100. So d can be either 10, right, the square root of 100, or -10. But you got to think about the problem, though. D represents a distance. So we're not going to consider negative distances. Alright, so no negative distance. Okay? So here we go. The distance between these 2 points is 10 units. If I went from here to here, it's 10 units long. Fantastic. And that is exact, right? And you don't need to round to the nearest tenth or anything, because that's a nice whole number. But this procedure I just went through is the same thing I would go through for any pair of points. Same thing I'd go through for any pair of points. So let me write that here. And this is the distance formula. So if the points, pardon me, say the points have coordinates x1, y1, and x2, y2, then the distance is the square root, right? You saw I took a square root of 100 here. The square root of the length of that horizontal leg, which is the change in the x-coordinates, right? So subtract the x-coordinates, x2 minus x1, and squared, right? It was that 6 squared, the change in the x-coordinates squared, plus, and the same thing for the vertical leg, squared, the change in the y-coordinates squared, y2 minus y1 squared. Right. And this is huge, right? I'll put this in a, this is what I'm going to be using for the rest of the video, right? You just subtract the x-coordinates squared plus subtract the y-coordinates squared, and then take the square root of that sum, and that will give you the distance between the 2 points on the coordinate plane. Right. So I'm only going to draw a picture for the first one. Right. You can draw pictures if you want of right triangles for the rest of them, but now that I have the formula established, I do not need to draw pictures to find the distance between 2 points. Alright, so number 1, the distance is 10 units. Alright, example 2, exercise 4 in the book. So now I'm asked to find the distances between, the distance between point -7, -3 and the point 8,5. And like I said, you can draw this on these 2 points on the coordinate plane and connect them with a segment and draw a little right triangle. Nothing wrong with that. It's just now that I have the formula established to find distance, I can just use it. So this I'll call, x1 comma y1. And so x1 is -7. The first y coordinate, y1 is -3. And for the second point, 8,5, that's x2, y2. Now I just substitute these into the distance formula. D equals, the distance equals the square root, and make sure they make that big square root, right? You got a lot underneath this. Alright, the horizontal leg squared, so 8 minus -7. And then squared, right? That would be 15. 8 plus 7 squared. We'll get that in a second. Plus, and then the length of the vertical leg of the right triangle squared, which is again 5 minus -3. Five minus -3, right? Which will be 5 plus 3. That'll be 8 squared. Sorry about the little minus there. It's 5 minus -3. So I have the square root of 15 squared plus 8 squared. That's the square root of 225 plus 64, which is the square root of 289, which is 17 even. 17 units. All right, and that's it. All right, there's no need to round, there's no calculator use here. 17 is a nice whole number. And that's it. The distance between these 2 points on the coordinate plane is 17 units. All right, fantastic. Yeah, no picture necessary. If you want the picture, draw it, but if not, don't worry about it. As long as you have this down, right? And again, this comes straight from the Pythagorean theorem, right? This distance formula. And I'm just going to keep using this. Next question. All right, example 3, exercise 6 from the text. So again, I'll label these points, the coordinates of these points. We're asked to find the distance between -1, 3 and 5, -5. So again, this is x1, y1 for the first point, x2, y2 for the second point. Alright, and the distance between them is equal to big square root. And then first is the change in x squared, change in the x coordinates, 5 minus -1, or -1 minus 5, it doesn't matter, because you're going to be squaring anyway. It'll just make it positive anyway. But I'll do 5 minus -1, right, the change in the x coordinates squared, plus, and then the change in the y coordinates squared, so -5 minus 3 squared. Okay, so this is the square root of 6 squared plus -8 squared, but it's going to be squared, so it'll end up being positive anyway. So it's the square root of 36 plus 64, the square root of 100, which is again 10. The distance between these points is 10 units. Easy, easy. And again, that's nothing that needs to be rounded to the nearest tenth or punched in a calculator. It's a nice whole number again. Fantastic. Again, you can draw a picture if you want, but I'm just going to keep going using the formula. Alright, example 4, exercise 8 from the text. Again, I'll label the points. You don't have to, but -8, -2, that'll be x1, y1. 7, 6, that'll be x2, y2. And the distance between these 2 points is the square root, right? Big square root of the change in the x coordinates squared. So 7 minus -8. 7 minus -8 squared. Plus, and then the change in the y coordinates squared. 6 minus -2 squared, right? All this under the square root. Alright, so this is the square root of 7 minus -8. Is 15, right? So 7 plus 8. So that's 15 squared. Plus, and then 6 minus -2 is 8. Right? 8 squared. That's the square root of 225 plus 64, which we've seen again already. That's the square root of 289, which is 17. A nice whole number. Alright, so number 1 and 2 were 10 and 17. Number 3 and 4 were 10 and 17. Please know that that does not always happen. Okay? Just it depends on the points that you're given, right? It's not always, and it's not always going to be a nice whole number. I'm sure we'll get to an example where it's not a nice whole number eventually. But the distance between these 2 points is 17 units. They are 17 units apart on the coordinate plane. Great. Let's keep going. There's one more page here. Hopefully we don't get 10 and 17 again. And based on looking at these ordered pairs, I don't think we are. So example 5, exercise 10 from the text. Again, I'll label the coordinates. So this point, -1, -2, that's x1, y1. And -3, 4, that's x2, y2. All right, now that I have the coordinates of the points, the distance between them is, again, big square root. And the first thing I'm doing is the change in the x-coordinates. So -3 minus -1, which would be -3 plus 1 squared, right, and square it. Plus, and then the change in the y-coordinates, right, 4 minus -2. So 4 plus 2, that'll be 6 squared. Alright, so this is the square root of -3 plus 1, that's -2, but that's being squared, right? So that'll end up being positive 4. 4 minus -2 is 6, right, squared, 4 plus 2. So we have the square root of 4 plus 36. This isn't a nice perfect square. This is the square root of 40. 40 is not a nice perfect square. This is not going to be a whole number. Now you may recall, you're going to be asked, of course, to simplify any radicals, any roots that are still left. Remember, the square root of 40 I can break up as the square root of 4 times the square root of 10. So that's 2 times the square root of 10, right, as a totally simplified radical. So the distance between them, these 2 points, is 2 times the square root of 10 units. Right, and this would be considered exact form, right, where I leave it the way it is and don't punch it into a calculator, don't round it. Right, this is the exact form right here. When they talk about exact, right, just leave it the way it was. But I'm going to punch this into a calculator and round to the nearest tenth like they asked. Right, so pulling up a calculator here. 2 times the square root of 10, or just the square root of 40, right, same thing. And that, if I'm rounding to the nearest tenth, that would round to 6.3. Alright, so this is about 6.3 units. So the distance is approximately, right, equal to wavy equal sign 6.3 units apart. And that's the second thing they asked us to do, is round to the nearest tenth, right? And this is an approximation. Right? Something that's close to the exact answer, right? But not exactly because it's rounded. All right, great. All right, and this is the last question, right? Notice I'm doing the same thing every time, right? We're given order to pick 2 points on the plane. Again, you can draw a picture, make a little right triangle if you wish, then use the Pythagorean theorem, or I'm hoping that you just have the distance formula memorized. It's not a tough one. So -4, -5, that's x1, y1. 7, 4, that's x2, y2. And the distance between these points on the plane is the square root, right, big square root, of the change in the x-coordinates squared. So 7 minus -4, which will be 7 plus 4, or 11, and then you're going to square that, plus, and then the change in the y coordinates squared, 4 minus negative 5. And then this change in the y coordinates is squared as well. Alright, 7 minus negative 4 is 7 plus 4, that's 11. Alright, and that's going to be squared. Plus 4 minus negative 5 is 4 plus 5, that's 9. And that's going to be squared. Alright, 11 squared is 121. 9 squared is 81. And we're getting the square root of 202. The square root of 202. And that's 2 times 101. And 101 doesn't factor any further. 2 and 101 are both prime. So there is no perfect square that goes into this evenly. Right? So I can't simplify that any further. So the distance between these 2 points is the square root of 202 units. Right? And if you leave it like this, right, this is the exact form, the exact answer. And then we round it to 1 decimal place, round it to the nearest tenth. So the square root of 202, about 14.2 units. So I'll write that here. The distance between these 2 points on the plane, the straight line distance, is about 14.2 units. And again, this is an approximation. Right? This is not the exact answer. It's close. It's a guess. It's a roundabout version of it. Right? Wonderful. And that's it. Right, that is all. So again, I would hope that you remember the distance formula. Right? Now you can always draw pictures of right triangles and use the Pythagorean theorem to find your distances. That's fine. But please understand that this isn't that hard to remember, I don't think. Distance between 2 points is the square root of the change in their x coordinates squared plus the change in the y coordinates squared, and then you go about and simplify it. Wonderful. Alright, I'm hoping that watching me do these 6 questions here helps you when you're asked to use the distance formula on your own. And thank you very much for watching.